Moving on for homework 43, this is the second part of the presentation. All right, we just did a couple of foiling problems. Now, root 7 plus 2 squared. We just talked about something like this. These guys are stuck together with a plus or minus, so you cannot just distribute the squared to both of those. It'll give you the wrong answer. What you need to do is, what does squared mean? Squared means times by itself. 2 times. So that means it's going to be this guy, root 7 plus 2, that guy times himself, right? It just means this guy times itself 2 different times. Okay, so here we go. So what do? Just like the last 2 problems, FOIL. Square root 7 times square root 7, that means that's just 7, right? Root 49, 7. So 7. And then outside is going to be plus 2 root 7. Inside is going to be plus 2 root 7. And then last is 2 times 2 is 4. All right? Positive times positive, positive 4. Well, 7 plus 4 is going to be 11. 2 root 7 plus 2 root 7 is 4 root 7. And believe it or not, it really is that easy. I'm not just making this up. Cha-ching, there you go. Okay, exact same idea with this guy, right? Do not just distribute the squared to both of these. You will get what's called the wrong answer. Okay, we don't want the wrong answer. We want the right answer. So you write this thing out 2 different times. Okay, and then you FOIL at this point. So here comes FOIL. This guy times this guy. 3 root 5 times 3 root 5. Here's how I do it. Watch. 3 times 3 is 9. Square root 5 times square root 5 is 5. 9 times 5 is 45. So actually, let me write it out like this. 3 times 3 is 9. Root 5 times root 5 is 5, so it's going to be 9 times 5, which is 45. So I thought that'd be a good way to do it, I guess. Okay, down here, look what's on this. First of all, positive times negative is going to be negative. On the outside, 3 times 4 is 12 on the outside. Square root 5 times square root 3 is square root 15 on the inside. So 3 root 5 times negative 4 root 3 is minus 12 root 15. Same idea here. Look, negative times positive is negative. 4 times 3 is 12 on the outside. Root 3 times root 5 is root 15 on the inside. It's also minus 12 root 15. And then finally last. Now be careful with this last, because it's negative times negative. So it actually becomes positive, right? 4 times 4 is 16. Root 3 times root 3 is 3. So that becomes 16 plus times 3, which is 48. So we get 45 minus 12 root 15 minus 12 root 15 plus 48. That's what we have so far. Okay. Well, guess what? These 2 guys are just integer numbers. I can add 45 and 48 together. 5 and 8 is 13, right? Carry the 1. 4 and 4 is 8. With 1 more is 9. 93. These guys add up to 93. Minus 12 root 15 and minus 12 root 15 is minus 24 root 15. Now, if root 15 simplified, like it was root 18 or something, then we would continue simplifying. But square root 15 does not have any perfect square factors, so it does not simplify at all. So this is the great and mighty answer. All right, so that was multiplying radicals. Now we're going to try a little bit of dividing radicals. Okay. Now dividing is usually not as much fun as multiplying, and it's pretty much true in this case, but it's kind of different than your standard dividing. Here's the deal. There's a rule When you have a fraction, because a fraction is just division, this is square root 7 divided by square root 2. When you're dividing with radicals in them, you're not allowed to have radicals in the denominator. No radicals allowed in the denominator. Right now we have root 7 over root 2, we have a square root 2 in the denominator. That is not okay. We can't leave it like that. It's not simplified. So we have to figure out some way to make the denominator not have a root in it. And the easiest way to do that is to say, how can I turn ugly square root 2 into a beautiful integer, nice number? And to me, the easiest way to do that is to make it into the beautiful number 2. The beautiful number 2. Now, how do I do that? Well, what is square root 2? The number you times by itself to get 2 for an answer. So, if I want to make this into 2 down here, then I would have to multiply this guy by itself. Look, root 2 times root 2 would give me 2. Check it out, square root 4, 2. But if I want this to be, if I want this thing to be equivalent to this thing, the way you make something equivalent is you can times by 1. Like 5 times 1 is 5, right? Anything times itself is that number. So I need to make this a 1. How do you make a fraction into a 1? Well, it's the same thing over the same thing, like 5 over 5 or 8 over 8, or in this case, square root 2 over square root 2. Whatever I do to the bottom, I have to do to the top. So notice, I'm taking this guy, timesing it by 1 in this form right here, root 2 over root 2, and that will give me a 2 in the denominator, and root 7 times root 2 is root 14 in the numerator, and that is my answer. Cha-ching. Now, what you might be thinking is this. You might be thinking, wait a minute, 14's an even number, 2's an even, wait a minute, can I cancel that and make that like root 7 or something like that? Cancel out the 2's? And the answer is no, you cannot do that because this is under a root. This has a square root of 2 basically, and this is 2, and they're different. You cannot cancel, even if they have a common factor, if one of them's under a root and one of them's not, they're not the same thing. You can't cancel them. So this is as simple as that gets. Okay. Similar idea here. Now, I could say, wait a minute, I don't want square root 75 in the bottom. I don't want square root 75 in the denominator. So I could do it by multiplying. I'm not going to do this. So if you're taking notes, which is not a bad idea, do not write this down. I'm going to erase it in just a second. I just want to show you what's possible though. You could say, well, to get rid of this root 75 in, I could just times by the same thing, root 75 in on top and root 75 in on the bottom, but that's not what I'm going to do. I'll show you why in just a minute. It's going to be easier. I like to do things the easier way, so hopefully you guys do too. It'll be easier if I actually simplify this first. Let's do that. So I'm not even going to mess with the top. I'm going to simplify the bottom. Root 7 over square root pretty, square root ugly. What is pretty about 75? Obviously, 25, because remember, 3/4 is 75 cents. And then there is, what's ugly? 3. Then what's pretty about n? Nothing. So it looks like that. Now let me simplify that. Root 7, square root 25 is 5. 5 root 3n. So, the nice thing about that is I don't have to worry about the 5. The problem here is the square root 3n in the denominator. The 5's not a problem. It's okay to have a non-square root number in the bottom here. So instead of having to multiply by root 75n on the top and bottom, and then that would require me to have to do a bunch of canceling at the end, but here's what I'm going to do. I'm going to multiply by this guy, root 3n. That will give me 3n, right? But I don't need to worry about the 5 because the 5's not the problem. The 3n's the problem, the root 3n. So I multiply the top and bottom by that. Now look what happens. On the top, I get square root 21n, right? 7 times 3, root 7 times root 3n is root 21n. And this is going to be 5 Root 3n times root 3n is just regular 3n. 5 times 3n in the bottom. So here's what it becomes. Root 21n over 15n. Now, some of you might be thinking, oh, I can cancel the n's. Or I can take a 3 out of both of these guys. Neither one of those you can do because this is underneath a root and this is not underneath a root. So unfortunately, the bottom line is that is the answer. You can't simplify it any more than that. Okay? Then, finally, this is the last problem before the homework. 2 root 80 over root 7. Here we go. I'm going to simplify root 80 because I don't have to do 7 times 80 and get 560. I would rather simplify this. You could multiply by root 7 over root 7 right now, but it's easier to simplify this guy first. So that's what I'm going to do. 2 times root pretty, root ugly. What is pretty about 80? Well, in case you didn't know, 16 times 5 is 80. So what's pretty? 16. What's ugly? 5 over root 7. And root 16 is 4. This is 4. So this becomes 2 times 4 is 8 times root 5 over root 7. So we get 8 root 5 over root 7. Now, root 7 downstairs is not acceptable. So I multiply by root 7 over root 7, and it gives me 8 times root 5 times root 7 is root 35. I can combine them together under the one root. Root 7 times root 7 is just regular 7, and that is the answer. Cha-ching. So, that is how you simplify radicals with division and also multiplication. So that is your